There's a quote that I like very much. It comes from a famous intellectual by the name of Sherlock Holmes.
The new idea of quantum mechanics in the early part of the 20th century was that whereas Newton said, "Tell me how things are today, and I will predict how they will be tomorrow." The universe is like a giant clockwork. I'll use my mathematics to turn the crank forward and predict how things will be. And the observations established that that way of thinking about things was very accurate when applied to everyday objects like glasses, or to the moon's motion, or to a rock that you throw. Newton can tell you what will happen. You do the observation and it does happen. Great.
When you have eliminated all that is impossible, whatever remains must be the truth, no matter how improbable.
Because you look at the observable universe, which is the piece of the universe and beyond, indeed, that we are claiming to understand and are indeed understanding in detail, and you realize that maps like this show you there are 350 billion large galaxies in the observable universe, which is 90 billion light years across.
When people began to probe the microscopic realm, that whole structure began to fall apart.
Different universe there.
Completely different universe, completely different realm. I don't want to, let's not, use the word universe in too many different ways tonight.
The thing I'm going to tell you tonight is one of those things which seems nutty, it seems wildly improbable, but it wasn't just something that some of us, I wasn't alone in saying this, that some of us just said, oh, one day, maybe the world is a hologram. That's not the way it happened.
A completely different environment. Okay. And in some way you shouldn't be so surprised. Why should the laws that work on everyday scales also work on tiny scales? And it turns out that they don't. The new laws, the laws of quantum physics, and the new idea of quantum physics is that you can only predict the likelihood, the probability of one outcome or another. So if I'm not dealing with a rock or the moon, but an electron, and I want to know where it is, the quantum laws say, well, there may be a 50% chance that it's over here, and a 50% chance that it's over there.
And we claim to understand how all that interacts, what it's made of, and indeed where it came from. And I think the size of our quest, the almost hubristic nature, becomes quite obvious. I just say that, just to set the scale, that's the billion light year ruler. I mean, the numbers are really quite ridiculous. The universe is big, I suppose, is what I'm trying to say.
The way it happened was exactly this way. When you eliminate everything that's impossible, whatever is left over must be the truth.
Even though the probabilities of quantum mechanics are confirmed by doing an experiment over and over again, finding the electron 50% of the time here and 50% of the time here, how do you go from the fuzzy, hazy, probabilistic mathematics of quantum theory to the single definite reality that we observe when we do an experiment? Nobody has answered this question yet, shockingly.
galaxies in our universe seem to be achieving an impossible feat. They are rotating with such speed that the gravity generated by their observable matter could not possibly hold them together. They should have torn themselves apart long ago. The same is true of galaxies in clusters, which leads scientists to believe that something we cannot see is at work. They think something we have yet to detect directly is giving these galaxies extra mass, generating the extra gravity they need to stay intact. This strange and unknown matter was called dark matter, since it is not visible. The name of dark matter is used to describe matter that can be inferred to exist from its gravitational effects, but does not emit or absorb detectable amounts of light. Observations of the rotational speed of spiral galaxies, the confinements of hot gas in the galaxies and clusters of galaxies, the random motions of galaxies and clusters, the gravitational lensing of background objects, and the observed fluctuations in the cosmic microwave background radiation require the presence of additional gravity, which can be explained by the existence of dark matter. Unlocking the secrets of dark matter and dark energy may prove the existence of the multiverse, but current models may hinder that exploration, thus calling forth the need for a unification model. The multiverse scenario states that our universe is only one of a very large number of universes, and in such a case, our particular universe may be referred to as a mini-universe or a pocket universe. Of course, our universe is already enormously large. It's just that the multiverse is gigantically larger than that. With eternal inflation, the multiverse keeps inflating in other regions, portions of which will later settle out into other pocket universes. The three main multiverse theories. 1. More universe like our own that came from the same Big Bang, but isn't observable. 2. Or it could mean more universe like our own that came from different Big Bangs, but that originate from the same common inflationary state. 3. Or it could mean a wide variety of universes, some like our own, and some different, with different constants and even laws governing them. The multiverse may be finite in size and the number of universes, or it could be infinite. If we accept the Big Bang and modern cosmology, then the first one is definitely true. If we accept cosmic inflation, then so is the second one. And if we accept certain models of string theory or other unification ideas, the third one may be true as well. And as for the finite or infinite question, that's still something we don't know. There's a theorem that says inflation couldn't have gone on forever, but there are loopholes that may allow to have done exactly that. The multiverse theory is still in its infancy, and some conceptual problems remain to be resolved. But as Leonard Susskind wrote, I would bet that at the turn of the 22nd century, philosophers and physicists will look nostalgically at the present and recall a golden age in which the narrow provincial 20th century concept of the universe gave way to a bigger, better multiverse of mind-boggling proportions.